What's up guys, today we're going to do the next part of the tutorial on how to build taillight yourself. We're going to go over the electrical parts and specifically what you get when you buy an Illumaesthetic taillight kit. So first off, you're going to be getting these laser cut panels. These are pre-made, pre-formed, and we don't know if we want to etch them yet. That's something we'll have to decide later. But these will come with specific designs, or you can design your own, and they'll come specific for your vehicle. So this particular set is a G35 set. Thank you, Fernando, for allowing us to use this as an example. And you can see that it's pre-cut, it's very clean. And normally these would come with a paper cover that we don't peel off, but for display purposes, we're taking it off. So let's take this away. And these are generally the other materials you get when you buy a full kit. So we're gonna start with this. These are just resistors that are required to be wired with the LEDs. This is kind of an example of what it would look like. So you see the resistor would go there. I'll get into this later, but they'll come in 3 different values for different kinds of applications, and we'll explain to you how to use it in this video. Next up are just gonna be assorted LEDs. They're just standard 5mm through holes, and for this particular case, we do highly recommend you do get Illumaesthetic LEDs. We've been in this industry for 2 or 3 years now. We've experimented with multiple LED manufacturers, and we've chosen what is essentially the best bang for your buck. We highly recommend you not get the eBay style LEDs where it's like 20 bucks for 1,000, because those tend to be lower quality LEDs, and you don't want to spend 40 hours doing a build and then find out that all the LEDs you use are bogus. So definitely use the good LEDs. We sell them by the bag, or we sell them by the 100. They're a pretty good deal. Definitely cheaper than most US-based companies that sell LEDs. And then finally, this is our in-house dimming module. We use this specifically for Illumaesthetic LEDs. There are cheaper models for more general use, but this is co-developed with our boards, and there's slots for 12-volt regulators to help regulate the LED voltage, as well as a 10-volt regulator to convert dimming instead of PWM for reliability reasons. So yeah, let's get into how to wire the LEDs. So real quick, we're going to go through what materials aren't included but are needed. So obviously the big one is you're going to need a soldering iron. This is the personal one I use. It's an AOU 469. You can get it on Amazon for only 30 bucks. Solder, we use 6040 leaded in this particular case. You preferably want to use rosin core. It does make life easier. Next up, we just have assorted wires. Nothing too fancy. Various threaded, stranded, and solid copper wire with no insulation. Your various electrical tools, so wire strippers, snips, pliers, and then last but not least, entirely optional but highly recommended, an adjustable power supply. This allows you to test the LEDs after you're done doing various stages of wiring, and it basically allows you to test individual LEDs. If you burn LEDs out, you can kind of figure out what burnt out. This isn't too expensive either, it's $40. All in all, everything you see on this as far as tools goes under 100 bucks, and that's all you need to get started. So let's go ahead and just jump right into doing some examples for builds. Now that you know the materials, we're going to actually go on an online resource called the LED Array Wizard. So here, this is the LED Array Wizard. This is a great tool to use for figuring out LED counts and resistor counts. So you're going to take your source voltage, which is 12 from the battery of the car. Your diode forward voltage, this is something that you pull from the data sheets that we give you when you buy the Illumaesthetic LEDs. In this case, we're going to do the red LEDs, so it's going to be 2.0. Diode forward current, we like to run our LEDs slightly lower to save the life, so we're going to do 12 in this case. And number of LEDs, this is an arbitrary number, but for this purpose, we're just going to say 31. So design my array, and you can see we don't recommend doing groups of 6 because the 1 ohm resistance isn't that great, but we do use the groups of 5 and the groups of 4. So you can see here 180 ohms, 390 ohms for the groups of 4, 380 ohms for the groups of 5. And if you just play around with this, you can see if you want it slightly brighter, You can turn it up to 15 and you'll see 150 ohms, 270 ohms, and if you want to do 2.1 based on whatever value, you see 100 ohms, 270 ohms. So this is a great tool for figuring out what resistor values and what groups of 5 you can do. So you can see here, these are 5 LEDs in series, and then each group is in parallel. If we do, for example, the white LEDs, which is higher in voltage, it's 3.2 volts, you can see 180 ohms, and then 390 ohms for the groups of 2, and then 680 for the groups of 1. So keep in mind for your resistors, the wizard thinks quarter watt resistors are fine, and then half watt resistors for this. So use this tool. It's a great tool for designing your arrays, and it's a great tool to learn how to do wiring. And we're going to basically use this to apply it for when we start wiring. Okay. So now that you guys kind of get an idea of the resistor and the circuitry required for the light through the website, I'm going to show you hands-on how to mark up the lights, kind of in a way to prepare for them. So over here I have an Evo 9 light, and here I have the G35 light we did earlier. I've already marked this one just into the groups. So this is the white section, this is the reverse area, this is the turn signal, this is the brakes. And so we know that from the inputs we have, the reverse section needs to be in groups of 3 and leftover groups of 1. For the yellow and red, they basically have the same chemical composition, so they're going to be groups of 4 and 5. So in this particular case, I'm going to basically go through the yellow and white for you guys. So kind of just draw it out. So these are all groups of 3. And then you can see here that we have 2 leftover groups of 1 right here. Yeah? And for the whites, for the yellows, I'm just going to draw lines diagonally. So you see there's a group of 5, group of 5, group of 5, group of 5, here, here, here. So these are all groups of 5. And then kind of get a little creative here. So let's see, this is a group of 5, this is a group of 5, and actually this won't work. So I'm gonna have to so you want as many groups of 5 as possible, and then limit the groups of 4. So in this case, it looks like we're gonna have 4 groups of 4. So here, this is a group of 4, and then you have 2 groups of 4 right there. So that gives me an idea of how to wire it, and then and how to plan out my LEDs. So this is the Evo 9, and actually I've already had the liberty of doing the G35 one. So for the G35, I'm going to draw this out a little as well. But for the G35, this ring, or this large section, is the reverse that I'm outlining right now. And you can see there's actually all perfectly groups of 3. And then this middle ring that I'm drawing out here are groups of 4 and 5. So you can see 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 4, 5. Right? And then same story with the outside ring, which is red. So that kind of gives you an idea of how to wire it. And now we're going to go ahead and start putting LEDs in. Alright, so for this example, I'm not going to do the whole light, but I will do a section of the turn signals. I do want to warn you guys, this isn't the easiest thing in the world. I'll try my best to explain everything, but if you don't know how to do basic electrical, I do recommend you read up on some tutorials. I'll try to include some links in the description of the video just to kind of get you guys up to speed. But for now, I'm going to start wiring. So real quick, LED 101. This is an LED. You can see that there's a longer end and a shorter end. For every LED, regardless of the manufacturer, the longer end will always be the positive end of the LED, and then the shorter end will be the negative end. You can also see, maybe it's a little hard to see, but some LEDs have a flat end. That's to help you mark which end is positive or negative. However, it is not consistent between all LEDs, which means that it's consistent within each particular batch, But you can't assume that the flat end is going to be negative on all the LEDs, if that makes sense. So I'm going to start, and I know that this ring is the yellow, and I'm going to basically have these LEDs all share ground, even between white, red, and yellow. So what I like to do is I personally like to have all the LEDs facing a particular way, so you can see the positive end is forward, negative end is backward, and I'm just going to start putting them in. So, like that. And the nice thing about Illumaesthetic boards are that they're specifically cut to be the size of the Illumaesthetic LEDs. So you can see that I'm actually not using any glue of any sort, and they're pressing in. So you see I'm pressing down on it, and it's not popping out. Sometimes they are a little big, and sometimes they are a little small. You just have to kind of deal with it. So here, this is the group of 10. So imagine basically this all the way around. Now what you're going to want to do next is take your snips and cut them approximately 3/8 the way down. It really depends on how close the LEDs are for your particular design. So we're just going to go ahead and cut them all. And now what you're going to want to do is you're actually going to want to fold down the leads. So at the beginning of each group, you just fold down this way, and then you fold down positive to negative. And that allows you to basically get everything ready for solder. So you want to fold down everything except for in between two of them, because they're going to be used for the resistor. So in this case, I'm going to leave these two folded up, and I'm going to fold these last two down, like so. And then for this, I guess since we're only going to do these two, I'm going to just solder these together. So this will be the positive end, so this will be the live end, and then this will be the ground end. Ooh, this is actually too short, so I'm going to replace this. There we go, better. So now before you solder, you're going to grab the correct resistor value for the yellow groups of 5 that the array wizard told you about. In this case, I'll be using 110s just because it's what I have on hand and it's within spec. So I'm actually going to take the lead and wrap it around this pin. That way you have a strong mechanical connection. Same story here. Just wrap it around, push it down, and I'm going to fold it over so it's out of the way, like so, and then just snip off any excess. Okay, and then do the other one. So wrap it around, make sure it's nice and strong. Push it all the way down, same story here. Push it out of the way. And that should be good. So now just trim. I cut too much. Oops. For demonstration purposes, this will be fine, but definitely don't do what I just did. So now, grab your soldering iron, and you're going to solder it. So don't use too much solder and don't hold it for too long, otherwise you run the risk of burning the LEDs. definitely don't inhale the smoke deliberately. This is leaded solder, so you do want to wash your hands after soldering, and you want to have good ventilation. The smoke isn't terribly hazardous, but it's definitely not something you want to be consuming on a regular basis. So let's go ahead and get the rest of this soldered up. Should be good.
Move your hands away for a second.
This is a very quick mock-up. I do want to fix some things. Definitely make sure that you have enough solder on everything. Everything's nice and shiny. Again, this is not an electronics class, so I can't teach you how to solder, but this is a general idea of what you want. So basically, imagine that this is extended all the way through, and instead of just these two touching, it extends all the way through. So you want all the positive ends of each group of 5 touching each other, and all the negative ends of each group of 5 touching each other. So now I'm going to take my power supply, verify that it works. And it looks like I used a red LED on accident, but that's fine. But you can see that it does work. And this is why having a power supply is good, because you can test in between sections. So actually what I'm going to do now is I'm going to set my power supply to 2 volts. 2 volts. And then limit the current to make sure I don't blow out LEDs. Go. And then test to make sure that this LED A works and is yellow. So it is yellow. So I'm actually going to take this LED out. Accelerate it. Put the yellow one in. We're back in business. So if I turn this to 12, and there you go. So you see everything's nice and yellow. Alright, so once you're done doing this one section and you extend it all out and have everything connected, you should eventually get something that looks similar to this. So, granted, there are many different ways to do this. This is the way we like doing it, so I'll just kind of point out some key features. This particular section is very similar to the section that we just soldered. The only difference is you see these are actually positive. Oh no, sorry, these are ground rails that run along the whole length of the light. They're jumped here and everywhere to basically make sure that the entire grounds are all connected. These center lines are power wires, so we like to use copper wire to keep it around. We tack weld it with shugu in various places to make sure it doesn't vibrate out of the way. But this is more or less what you expect. So I'm going to kind of just see if I can point out. You see this is the group of 4 here. So you can you get both ends? So you can see these are all the groups of 3. So you can see here 3, 3, 3. These are all whites. And if I put it up to the power supply, pick it up, you will get to see that it all works wonderfully. So you see, these are the brakes.
This should be the reverse. Nice and bright. These should be the turn signals.
Right, so this is kind of the general gist of how to wire. I'll do what I can to provide as many tutorials or online references for the guys that don't know how to solder, but this is kind of the general idea. You see, the only things that you do need to provide yourself are obviously the tools, the copper wire, and the wiring. All the LEDs you see here and the resistors to go with them are included, the board is included. So, hope to see you guys in the next section. Definitely, we'll try to see if we can get something set up that helps explain stuff a little, make this a little easier for you guys. And maybe in the future, if you guys will definitely have enough demand, we can start selling pre-wired boards. So that's the episode of Electrical with Illumaesthetic. Next, we'll be doing either the fitment of the board or how to wire the control module. So I'll see you guys later. Take care.